just recall that if f is a continuous function on this interval ab, and I take a number x between a and b, and here by that area I define this function capital F of x, okay, then capital F is a differentiable function and its derivative at x is simply obtained by substituting x in place of t. Now, what we are proceeding towards is this. We have a function g of x, which is defined using this continuous function square root of 1 plus t to the 4. And here in the upper limit, instead of x, we have a function of x, say sine x. And what we would like to obtain is the g prime of x. So the problem in using this form is this, just like when you did derivatives, in the beginning, is that instead of x, I have sine x. So what we will do is that we shall, just like we did in the using the chain rule before, we are going to assume that, say, u is sine of x. So now u is a differentiable function of x. So what we got here now is that we have gx as a function of u and u is a function of x. So if we go ahead and we are looking for g prime, that is dg over dx, then what you can do is that you can write it as a product of dg du, that is the derivative of g with respect to u first, and then multiply it by the inner portion the way you did before, that is du dx. Okay, so in this case what happens is, this is the function of u. When I differentiate it with respect to u here, we'll have the same technique as we did here. So what will happen is that all we will do is that substitute u in place of t, okay? And then the next part is what? Du over dx, and u is how much? Sine of x. So how much is du over dx? That is simply cosine of x. So now we are ready to write the final answer, that is dg dx, which is the g prime u that we wanted. Okay, and that will, g prime x that we wanted, g prime at x, that becomes equal to this function as we just obtained, and we can just replace now u by how much? Sine of x, because that's what u was. So here we will write sine of x to the power 4, and this becomes the derivative of g with respect to x. All right.